So far, we've been using one metal element and one nonmetal element to make an ionic compound. You can also get cations and anions that come from a group of atoms that act as if they were a single unit, a single ion. As an example, we saw this earlier, NH4 with a +1 charge. That is called a polyatomic cation, and the name of it is the ammonium cation. There are many polyatomic anions, for example, NO3 minus NO3 minus, which is called the nitrate anion. These are all given in table 5.3, and this is the second big thing you need to memorize. In addition to the scientific prefixes, you need to know this table forwards and backwards. In other words, you need to know the name, hypochlorite, stands for ClO with a -1 charge. And notice not just the formula ClO, but also what the charge is. If you are given the chemical formula, then you should be able to figure out what the name is from memorizing this table. Now, this table is not that bad when you break things down into similar groups. We were just talking about nitrate. Right underneath nitrate is a very similar polyatomic anion, which is nitrite. The ones that end in 8 have a greater number of oxygens. And the ones that end in ite have a smaller number of oxygens. So this goes together with more of these, such as over here you have sulfate and sulfite. So if you can remember that sulfate has 4 oxygens, remembering that sulfite must have fewer, it's going to be SO3 2- instead of SO4 2-. If you add a hydrogen in front of that, that just becomes hydrogen sulfite, and the charge changed from -2 to -1. If you add a hydrogen in front of sulfate, it becomes hydrogen sulfate, and the charge also went from -2 to -1. Notice these could also be called bisulfite or bisulfate. You also have these 4 at the top of the right-hand column that all go together the same way. So here is the one I would start with, remembering chlorate has 3 oxygens. If you take an oxygen away, chlorate becomes chlorite, and now you have 2 oxygens. If you continue to take one away, we've already done the 8 to 8 trick. Now this becomes hypochlorite. Hypo means less or fewer, so we have even fewer oxygens. And the opposite of hypo is hyper, and in chemistry we'll drop the HY and just use the per part, and we've increased from 3 oxygen up to 4 oxygen. So here are 2 examples where we're given the name and we want to work backwards to figure out the chemical formula. So sodium permanganate. The sodium we know is a group 1 main group metal, so it always makes a +1 cation. Permanganate comes from this table, and permanganate has the formula MnO4 with a -1 charge. So if we do the crisscross 1-to-1 ratio, sodium permanganate is NaMnO4. Notice the next example, we can combine the Roman numerals when we need them with the polyatomics. So we have chromium 3 sulfate. Chromium is a transition metal, and the Roman numeral 3 is telling us we have a charge of positive 3. Sulfate, SO4, with a negative 2 charge, we get that from table 5.3. When we do the crisscross this time, the 2 subscript on the chromium is just like normal, but now we need a 3 subscript on sulfate. Whenever you have more than one polyatomic, you have to put parentheses around the whole thing. So this would be SO4 parentheses and then a 3. So this is chromium 3 sulfate. Notice in both of these examples, permanganate stays permanganate. We do not change the ending to an IDE. You only do that for nonmetal elements. So sulfur would change to sulfide, but sulfate stays as sulfate. That's true for all of the ions, all the anions on this table. Notice there's only one cation you need to remember, which is the ammonium cation. All the rest of these are anions. These named endings do not change to IDE. The reason for that is you could have the chemical chromium 3 sulfide. So the chromium is a positive 3 charge cation. Sulfide, we know, must have come from the sulfur element on the periodic table because it changed from sulfur to sulfide. Sulfide is a negative 2 charge because sulfur is found in group 16. Take the last digit 6, subtract 8, and when you do your crisscross, you get 2 chromiums for 3 sulfurs. So very similar names, but notice 2 different chemicals, so they have to have 2 different names. Chromium 3 sulfate versus chromium 3 sulfide.